Hi everybody, and welcome to our unit on, or our lesson on proportional and scale drawings. We are really researching the area of ratios and why we use them in real life. So we're going to start with, how do you do this? What really is it? We've worked with proportions, and now we're going to work with it in terms of drawing. So those of you who aspiring architects out there, listen in, because this is a big part of what you'll be doing someday. Okay, so I drew, no laughing, I drew a scale drawing of a car. Now, admittedly, this is not super exact, but we are pretending that the length here, if we got out a ruler, would be 2.8 inches, and the length here is 6/10 of an inch. Over here, you see that 1 inch is proportionate to 2.5 feet. So for every 1 inch that we would measure, that's an actual 2.5 feet on the actual car. What this is right here, and I've put it right up here, is a scale. It tells me what each inch is actually equal to, so that I didn't have to build an entire car. I can just draw a model of it. Or I didn't have to get out that many feet of paper to show you the car, to draw it. This actually, if you look right here, it works like a ratio. It is a ratio, in fact. Proportions, ratios, rates, all kind of work hand in hand together, and we'll kind of go through that. So all of this is really easy to see, but I want you to have the actual definition. So if you want to pause and write this down, the scale of a map, model, or drawing, it could be any of those things, tells how the map, model, or drawing's dimensions are related to the actual dimensions. That's a fancy way of saying this is to this. This is the drawing over here, and this is related to the actual car that exists, theoretically. So given all of this information up here, I want you to think along with me about how to find the actual dimensions of this car. And we are going to do that with step number 1, and we're going to set up a proportion. If you look right here, I just put 1 foot is to 2.5 feet, wrote it like a fraction, and it's proportional to, so I put an equal sign, 2.8 inches, and I have that because I know that the length, and notice I'm working with length first, 2.8 inches is to, we don't know how many feet quite yet. Okay, we are going to do the Ninja Star crisscross multiply, not cross reduce. We are going to multiply. And what I did when I did that is, when I go zoop like this, I get an x, because this is 1 times x is x feet, is equal to whatever 2.8, oops, I want that to stay a dot, 2.8 times 2.5. I went ahead and made these into in parentheses, which means multiplied together. I didn't want to use the multiplication sign because that looks too much like an x, and I didn't want to use the dot because I already have 2 decimals in here. So I used the method of the parentheses to show 2.8 times 2.5. And I've already gone through the process. You can check me out on my math here, because we all know sometimes Mrs. McKinley makes errors when I try to talk and do math. So I did 2.8 times 2.5. Here's my arithmetic. And I came down with a 7, well actually 700, but I had to swoop over 2 times because there are 2 total numbers after the decimal, so I swooped over 2 times, and that kind of makes sense because 2 times 2 is 4, but it's a 0.5 and a 0.8, so I'm kind of thinking 7 makes sense. X equals 7 feet. So if we were actually going to look at how big this car is up here, it would be 7 feet long. That's about a foot taller than Mrs. McKinley, a little more than that. All right, so now I want you to try this, the width. So why don't you go ahead and pause the video. I've already set up the proportion with you to just give you a little help. 1 inches to 2.5 feet as 0.6 inches is to x feet. Okay, so set up that cross-reduce product and then do some figuring. Okay, so when I look at this, I went right here, I'm going to have x feet, so I put that over here, and then I did 0.6 times 2.5, I put those in parentheses over here. My arithmetic showed me I got to 150, and I had to swoop 2 to the left because there are 2 numbers after the decimal, and I got 1.5 feet. So it's 1.5 feet across. So I would like you to take a look at this one. I'll move my camera so you can see it a little better. The actual distance from the front axle to the rear axle is 5.5 feet. Find its distance in the scale drawing. So now we are going to go backwards, and if you look up here, I'm looking for this length, and the actual is 5.5 feet. So we are going to use the same ratio as before. The 1 inch is to 2.5 feet. And then we don't know, the x is actually on top, and the bottom is the 5.5 feet. So when we do the crisscross ninja star multiply like this, we get on one side of the equation 5.5 equals, and then if we combine these two, it's 2.5 times 2 times an x. So how do we figure this out? Well, what we could do is we could divide both sides by 2.5. I haven't given myself a ton of room here, so I'm going to use a little space off to my side. And I'm going to pause the video after I've set this up, and I want you to give it a try. See if you can remember how to do this. So I have 5.5, and I want to divide it by 2.5. I want to remind you that this decimal is going to swoop over, and remember what you do over here. I'm going to pause the video. You try to figure this out. All right, here's the work that I have shown. Check me out, make sure I did it right. I got 2.2, and make sure it's labeled inches because the inches go up here. And notice the analogy. 1 inch is to 2.2 inches as 2.5 feet is to 5.5 feet. We're just setting up an analogy, more or less. The last thing I want to go through is the ratios of perimeters and areas. Sometimes this gets confusing for kids, and I'm going to actually pull out my math book, and I want to show you. I'll get the page number should you want to look back, but it's better if you can actually see the drawings. And this is on page 418 and 419. So let's take a look at the drawings. And I'm going to go through this with you so that feel free to take any notes you want, but with my drawing skills being as they are, I figured this would be the better way to show you. So it says this mural, a finished mural, is 20 feet by 10 feet. Your scale drawing of the mural is shown. So I have the scale drawing, 2 inches by 1 inch, and it is 1 inch is to 10 feet. So what is the perimeter of this drawing? So if we were to add that up, that's super simple, easy peasy lemon squeezy. 2 plus 1 plus 2 plus 1. So that's going to be 4 plus 2 is 6. Okay? What is the actual perimeter of the drawing? Well, this would be 60 because it's each inch is 10 feet. So it would be 60 feet. Hopefully you remember from last year, Mrs. Pettis told me you should remember that it's 2 length plus 2W. There's our 6 inches, and we got the 60 feet. So if we want a ratio of the perimeter of the drawing to the perimeter of the mural, if you have the words of what you want to compare, you would do 6 inches and 60 feet, which if you were to reduce that down, you're going to get 1 inch to 10 feet. That looks a lot like the scale we already see over here. So if you do the perimeter of the drawing to the actual, it will reduce down to what your scale is, or it should, if your scale is correct. So you do the same thing if you're going to find the area. I'm going to show you, this is kind of a cool looking little drawing in our book. Use the information in example 2. Find the ratio of the drawing's area to the mural's area. How is this ratio related to the scale? Okay, so now we're just trying to find the area. Let's find the area of the drawing. Easy. We have 2 times 1. Remember, it's length times width. So that's just 2 square inches. The actual would be 20 times 10. So 20 times 10 is 200 square feet. So here they have 2 inches squared over 200 square feet. So it would be 1 inch squared is to 100 square feet. So it's a 1 times 1 inches squared and a 10 times 10 inches squared. So ultimately, this is what you want to get to, but they're showing you here that you just break it apart. You just multiply the 2 sides to get the square inches or square feet, whatever you're looking for. So I wanted to show you in the book a couple of questions, and this one is rather difficult in the sense that it's hard to figure out why it works this way, but it does. So if I want to find the scale of the perimeter, the figures to the actual perimeter, and it's already reduced as a 1 inch to 10 feet, the directions here are asking you find the perimeter of a figure drawn to this scale to the figure's actual perimeter. Well, we just saw in our example, if it's 1 to 10, it's going to stay 1 to 10 because it will reduce to that. I'm going to try to find one that's really easy to reduce. Oh, if we find number 22, we have a 10 to 1,000. Well, I can reduce that. It would be 1 millimeter to 100 kilometers. You can reduce that. That will be your actual scale ratio when you reduce it down. But it also asks me a second thing. Find the ratio of the area to the of the scale to the figure drawn. All you need to do is say, okay, I need to do 1 times 1. Well, that's 1 inch squared. Well, what's 10 times 10? That's 100 feet squared. So your area ratio would be 1 inch squared is to 100 feet squared. For number 21, 15 centimeters is to 1 kilometer. Well, what you need to do for this one is you would need to do 15 times 15, which is 225 centimeters squared would be in your drawing, and it would be 1 kilometer squared in actuality. I hope that I explained that well. Have fun with your lesson today.